Hello friends, this is Dr. Mohammad Aslam FCA from Pulse Tutorial. In our previous video, we discussed partial least square, structural equation modeling PLS for no mediation model building. Today, we will discuss PLS SEM for partial mediation model. PLS SEM software is used for today's discussion. Its setup file with license key and working files for this video are provided with the link for your download and use. You can contact us by email, Zoom, or WhatsApp for any further assistance. The PLS SAM seems hotcake for social sciences research recently. It has been used widely in latest articles published in the high quality journal such as Web of Science and Scopus. Because it can deal with multiple variables containing multiple indicators or items for factor analysis and regression simultaneously. It is termed as third generation statistics for social scientists. We emphasize its applicability rather than technicality and used hypothetical theory and data set for your easy understanding. Let's discuss PLS-SAM partial mediation model building and reporting with multiple variables and multiple indicators or items in this example. Say, you found from previous literature that research attitude caused impact on organizational performance. It means earlier theory established that more research attitude had direct significant impact on better organizational performance. In addition, there might be any mediating variable like corporate culture, corporate leadership, etc. in between them for indirect significant relationship. It means if we put corporate culture as a mediator between the research attitude and organizational performance, then their direct relationship remains significant and indirect relationship also becomes significant as well. This is the sign of partial mediation when both direct and indirect relationships are significant. Of course, appropriate references are required for these relationships from previous studies. For example, Paul et al. 2021 observed this relationship earlier. Now, we want to explore this relationship to confirm or reject their previous findings with our research work and dataset. Firstly, we get research attitude as independent variable observed through RA1 to RA5, where RA1 means basic research, RA2 means applied research, and so on up to RS5. Secondly, we get organizational performance, OP, as dependent variables observed through OP1 to OP5, where OP1 means in-house performance and OP2 means communication performance, and so on up to OP5. In this model, we will discuss mediating role of a third variable between RA and OP. Then thirdly, we add corporate culture as mediating variable observed through CC1 to CC6, where CC1 means formal culture, CC2 means supportive culture, and so on up to CC6. In PLSM, variables are referred to constructs that are observed or measured through reflective or formative indicators or items. In this discussion, we make our model through reflective observed indicators like RA1 to RA5, CC1 to CC6, and OP1 to OP5 to represent their respective unobserved constructs, namely RA, CC, and OP. Let's assume our research is based on primary data. After setting the aforesaid indicators for independent and dependent construct, we need to prepare questionnaire for data collection. Here, we use 7-point Likert scale for respondent scores. How to enter data in the Excel sheet from filled up questionnaire and then transfer to CSV format for smart PLS data read are discussed in our videos earlier. Hope you have seen the videos and practice those working files for your understanding. Please open your installed Smart PLS3 software interface will appear. Click New Project in the toolbox and name PLS Partial Mediation Model. You will find newly created project in the Project Explorer. Here, double-click the data icon to import data from PLS-SEM Partial Model Mediation dataset CSV file provided with this video. Software will read the data and become green, meaning ready for operation with the dataset, and produce PLS-SAM partial model dataset text that's showing report for indicators, indicator correlation, and row file. We have previously done this model. How to do it is shown in my previous videos. Now I am opening this project. Here it is. Double click. This is the indicators. We have 18 indicators with no missing value. These are the mean, median, minimum, maximum, standard deviation, kurtosis, and skewness. That will give us the idea about the normal distribution of the data. Though PLS-SAM is a non-parametric test, it doesn't require the normal distribution, but to know our data characteristics and to be a safer side, we can see these figures. Now we will build PLS-SAM partial mediation model. PLS-SAM mediation analysis will be performed to assess the mediating role of CC between RA and OP. As you know, total effect equals direct effect plus indirect effect. This is our direct effect. We can see the figure from here. For design purpose, we ignore it for the time being and zoom in for our convenience. So this is the model. This is our direct relationship, and through this mediator, this is our indirect relationship. So direct relationship RA OP, RA CC, and CC OP. And indirect relationship will be RA CC OP. These are our research objectives with the respective hypothesis. For example, research objective 1, to find out whether research attitude cause direct effect on organizational performance. Relevant hypothesis will be research attitude causes organizational performance. For indirect relationship, the research objective is to find out whether corporate culture has a mediating role between research attitude and organizational performance. Relevant alternative hypothesis will be corporate culture has mediating role between research attitude and research and organization performance. So let's build our model with the data set. We have double click here and import the data set, and all the data set are showing over there as I have shown you earlier. Now we dress from this indicator here and made this model. This procedures is written in details over here, so I am not selecting it. And also they are referred to our previous videos. Now First, we prepare measurement model to check whether the model is fit for further analysis. If it is fit, then we prepare structural model to find our ultimate research objectives, the relationships among construct with respective significance level. So this is our measurement model. We calculate PLS algorithm, select factors, and start calculation. The report is ready. This is our final result, quality criteria, interim result, and base data. From this, we will find path coefficient, outer loadings, R square, construct reliability and validity, discriminant validity, and collinearity statistics as well. So among all these, we will speak with some specific value that is required for our measurement model very much. So this is the model. If we click here, we'll find this. These two are similar. We can copy it from here and put it to our destination file. I have done it previously, so I'm ignoring it for the time being. So this figure and this figure is almost the same one. This is the outer loadings. This is the beta value. This is R square, R square. So with this PLS algorithm, if we go here, outer loadings, we find this value, which is made the threshold level of 0.6. So we do not delete any item from here. For construct reliability, we go for front batch alpha, row alpha, and composite reliability. All these also meet the threshold level. This reference is given here. So our construct reliability is established. Now for construct validity, we have convergent validity and discriminant validity. For convergent validity, we put AVE, average variance extracted. These are the values. It also meet the threshold level. For discriminant validity, Cornell-Lorca criteria, this is the values. We see the diagonal values are higher than these values. So this criteria is met. Again, for construct discriminant validity, we can check it with cross loadings. From here, these values we can put here. We find out the respective construct items load is more on their own construct rather than the other construct. We have bolded out here, here, and here. So this criteria is also met. Now we find the Stmt ratio from here. These are the values. And we find that it also made the threshold level of 0.90 and it shows green. It means okay. So given the aforesaid calculated values as we have discussed, this model is fit for further analysis towards structural model. Now let's find the structural model. For the structural model, we first click here to the figure. Then we calculate bootstrapping. We go for no sign change, complete bootstrapping, bias corrected and accelerated bootstrapping, two-tailed test, 5% significance level. For the partial square, we put now path and keep everything remain the same and we start the calculation. It will give us the output in a very short while. You can see the report is being ready. Now we got the report. This is the bootstrapping report. The final result under path coefficient is is final result, quality criteria, histogram, and base data. From here, we can see our model. It will be exactly the same. In the same way, we can also export this image file here. I have previously done it. Now I ignore it. So you see, this is the picture. Now for model quality criteria, we got 2 points. One is predictive capability R square and another one is the path coefficient. So let's talk about the R square first. If you go bootstrapping results, this is our R square value, 8% and 35.7%. It means though the first R square is statistically insignificant, the second one is significant. Let's assume it is significant and interpret it. It means 8% variance in corporate culture can be explained by research attitude, while 35.7% variance in organizational performance can be explained by both research attitude and corporate culture. So let's assume the predictive capacity was established. Now we go for path coefficient. This is our path coefficient. These are the relevant paths, and I put the values over here. You see, these values are same. We got, for example, RAOP, this line. This line is here, RA to OP, and it is statistically significant. We can also get the confidence interval from here. These are the values. I put it here. So now we see that our H1 was accepted since the p-value is less than 0.05. Same is the H2 and H3. So these three variables are connected within themselves and they are statistically significant. So now we go for mediation analysis. For mediation analysis, we need to go for, this is specific effect, this one. You can see this is mediation effect. And you can also do that the p-value is significant. This is we put here. And we find it statistically significant. So since all the values, both direct and indirect, are statistically significant, we can make the decision criteria as referred here. We know no mediation, direct effect is significant and indirect effect is insignificant. Partial mediation if both direct and indirect effects are significant. Full mediation if the direct effect is insignificant and indirect effect is significant. So in this case, we go for 3 because all our direct and indirect effect are significant. So the decision is partial mediation. And as we know, total effect equals direct effect plus indirect effect. If we sum these two, we will get these two variables. So we have also finished our mediation analysis. Now our decision. As the direct effect was significant and the indirect effect was also significant, there was partial mediation in this model because both the ways are significant. I hope this video helped you to understand the partial mediation. Thanks for your time. In the next video, we'll discuss about full mediation. Thanks for your time.